So we need to determine the radius of convergence of the given series. We know that by the series ratio test, the series converges if limit of the absolute value of an plus 1 over an is less, where n approaches infinity, is less than 1. In our case, an equals negative 1 to the power of n times x to the power of 2n plus 1 over x over 2n plus 1, and an plus 1, so n plus 1's term of the series equals negative 1 to the power of n plus 1 times x to the power of 2n plus 3 over 2n plus 3. So the limit of an plus 1 over an, where n approaches infinity, equals the limit of the absolute value of negative 1 to the power of n times x to the power of 2n plus 1 over 2n plus 1, and this whole thing is divided by so this is the denominator, and in the numerator we have an plus 1, so we have this expression. Now let's try to simplify it. So this equals the limit of the absolute value of negative 2n plus 1 times x to the power of 2n plus 3 over 2n plus 3 times x to the power of 2n plus 1, where n approaches infinity. This equals the limit of the absolute value of negative n times 2 plus 1 over n times x squared over n times 2 plus 3 over n, where n approaches infinity. Then this equals the limit of the absolute value of negative 2 plus 1 over n times x squared over 2 plus 3 over n, where n approaches infinity. Now since n approaches infinity, then 1 over n approaches 0 and 3 over n approaches 0 as well. Then this equals the limit of the absolute value of negative 2x squared over 2, where n approaches infinity, and obviously this equals negative 2x squared over 2. Sorry, the absolute value of negative 2x squared over 2. Now we know that for our series to be convergent, this has to be less than 1. So we know that this expression is less than 1. That means that negative x squared, the absolute value of negative x squared is less than 1. So the absolute value of x squared is less than 1. So the absolute value of x is less than 1. So x is less than 1 but greater than negative 1. And this is the radius of convergence. So the radius of convergence equals 1.